We're looking for range and standard deviation in this section, which is 8.4. This is called measures of dispersion. So we're going to look at how far the data is spread out. That's what's called measures of dispersion. So this is 8.4, part 1. Okay, so there are two ways that we're going to measure dispersions in this class. We're going to look at what's called the range, and then we're going to look at computing what's called the standard deviation. So the range is the greatest data value minus the lowest data value. Or if you want to think of it, it's high minus the low. Okay? So when you do these, you got to find the largest one and the smallest one and subtract the two. So let's look at this example. It says find the range for the data set 14, 8, 11, 10, 12, and 10. Now, the lowest data value, or the smallest one, is 8. And the highest one is 14. So I'm going to take high minus low. So high again is 14. And let me just rewrite that because that does not look clear to me. So 14 minus the lowest one, which is 8, and 14 minus 8 will give me 6. Okay, so that is the range. So the range is 6 data set, or values. So find the range of the data, 14, 8, 11, 10, 12, and 58. So the lowest one is still 8. And the highest one is not 14 anymore, it's 58. So again, I'm going to do high minus low. So high is 58, and I'm going to subtract 8 from that. So this time around, the range is 50. Okay, so let's go ahead and look at this next one. Find the range of the data set 1,140, 1,180, 1,110, 1,100, 1,120, and 1,150. Again, I'm looking for the lowest value, or the smallest one, and the highest one. So let's look carefully. Okay, we're looking for the smallest value. All of them are 1,000, and it's in the 100 range. So I'm looking for the smallest one, which is the 1,100. And now I'm going to look for the highest one. The highest one of these are 1,180. Okay, and I'm just double checking because these numbers are pretty close to each other. So again, we do high minus low. So high is 1,180 minus the low, which is 1,100. And when I do that, I get 80. So 80 is the range of this data. How does an outlier impact the range? It impacts it a lot. Because it will affect the lowest value or the highest one. So if we look at the first example, I'm going to call that A, and I'm going to write that up there. The range was only 6. But when I stuck in part B, when I stuck in 58, it made the range be 50. So that's what they're talking about in outlier. So the outlier, 58 in example B, made the range much, much bigger. Okay? So the range tells us how far the lowest is from the highest value. So it tells us how far the lowest data value is from the highest data value. Okay. All right, I'm going to keep going in this video. I'm going to introduce standard deviation to you, and we're going to look at the formula. So when we look at standard deviation, we're looking at how far the data values are from the mean. Basically, we're going to average those distances. So we're going to see a little bit of that sigma is put in there. And then we're going to look at the formula. So it's for a sample, so sample population data. So standard deviation, and I'm just going to write SD for standard deviation. Okay, so standard deviation equals. Now we have a square root value in here, and whoa, that didn't work out too well. So let me try that. I'm trying to make it nice and neat for you. So I'm going to do this again. I'm going to do that. I just have to slow down. There we go. So underneath the square root, we have sigma x minus x bar squared all over n minus 1. Okay, so again, the symbol sigma means to sum. So we're going to sum up. X is the raw data value. Remember, x bar is your mean. So by the way, you're going to have to find this first. And then n is the number, or the total number of data values. Okay? All right, so what we're going to do is we're going to do a process. So I'm going to show you how I do this, so please, don't write down anything until you're done looking at it. So what I'm going to do is I'm going to make a chart. Okay? In the left column, I'm going to let that be the raw data points. So I'm going to write down all the raw data points. Okay? Now, I'm going to take x minus x bar. So again, you have to find that mean first. I'm going to find out what that is. So I'm going to take those raw data points, subtract the mean from them, and figure out what that value is. Then I'm going to take that value. Geez. I'm going to take that value, whatever you got when you did x minus x bar, and I'm going to square it. Okay? So I'm going to do that for every single data point that I have. So you might have data points that are like, you might have 5 data points, you might have 10 data points, but you're going to have that many rows as you do the number of values that you have, okay? So once you do the chart, you're going to use this column, and you're going to sum it. So next, sum sigma x minus x bar squared. Okay? Once you get that total, then you use the information. So you're going to take the square root of the sum of x minus x bar squared over n. Remember, n is the number of data points, minus 1. Okay? And then you take the square root of that. That'll give you the standard deviation. Okay, in the next video, we're going to actually run through this.